Hey folks, welcome to another episode of The Security Table. This is Chris Romeo. I'm joined by Izar Tarandosh and Matt Coles. And in this episode, we're going to dissect a bit this paper that we saw that Atlassian's put out to the world, The Paved Path to Balancing Security and Innovation. So first, a plug for the paper. I thought it was a well worth your time type of thing. It's 4 pages, so you don't have to go take a whole night to read it. It's very succinct, but has a lot of valuable things that they share in it. And there's one section in this paper, manage control with a 3-lever approach. And securing your internal environment while still providing teams with the flexibility to innovate, Bala recommends 3 main levers of control. And so Bala was this is the CISO from Atlassian, who was interviewed and was the main subject matter expert for this paper. And so we really want to just discuss the 3 levers that were shared here in the document as a way to get started. And so I'll throw the first one out because I feel like we've spent some time talking about this one. We can rehash it a tiny bit, but the first one was really have a secure by default approach. And so, first of all, what's the difference between secure by design and secure by default? Somebody give me that context.
Well, I guess you could refer to our earlier podcast episode about the CISA secure by design, secure by default document. But in a nutshell, secure by design is you build in controls so that your security your posture is quote unquote secure, and we'll probably want to dive into that a bit more. So you design into your system so you're not tweaking it at runtime. And then secure by default is when you deploy into a secure state. So your configuration is pre-secured, pre-hardened, locked down, no default passwords, no insecure protocols enabled, and you've turned all the knobs and dials and things to 11.
In other words, secure by design is you shouldn't be able to screw this thing up. And secure by default is you have the option of screwing this thing up, but from the start, we are putting it in a mode that shouldn't be screwed up.
And by the way, we know that it will run and operate correctly in that lockdown configuration state. We've designed it to do
that was
so.
Always the challenge with hardening, right? Hardening guidance is you'd get because, as I've said before on this podcast, I'm extremely old and I've been in our industry for a long time. And so I remember taking Windows servers, grabbing a document of hardening guidance and going line by line through the document, go change a setting. But the fun part was you'd always get to the end and you'd restart and it would lock up and it wouldn't boot anymore. And like something in the guidance would have caused it to no longer work. And so it was secure by default, of course, because no one was getting into it. Now we weren't able to use it either, but the attackers couldn't. So it was in fact secure by default. But that just makes me think about the olden days of hardening.
It was all crypto and permissions were the 2 things that broke everything.
Yep.
You suddenly couldn't get a console because nothing trusted each other, and or you're using a crypto algorithm that nothing recognized.
Yep. Windows would always get you to the blue screen of death as a way to know that you were basically screwed.
And then you have to boot into safe mode, right? Boot into safe mode and go driver by driver.
I remember Windows that's versions that didn't have safe mode. So you were just basically, you got to restart the install of we didn't ever put anything onto these servers before we applied the hardening guidance because we got smart along the way. Like, don't go install something else because you're just going to have to redo it when the thing doesn't start after. But I'm talking about ancient history here. So when we think about secure by default, cloud, this paper's talking about cloud infrastructure, trying to provide security controls as a foundation so the teams have the flexibility to get started with their work in line with security policies. At Atlassian, they have a very clear set of patterns on the types of hosted images that they allow, default configurations when you're spinning up and secure by default. They gave an example. Their S3 buckets, when they're created, they're only accessible within Atlassian's network by default. And these are built into a service that they have. So they're referring to this as like a paved path in this context. What do you think about that analogy of this being a paved path?
I think at the end of the day, if put in context, when we get to the third bullet, when we get to the security guardrails, the analogy here is there is one way to go. There are bumpers on the side to keep you on that path, right? And this is paved because somebody already took this road before. Somebody already walked in here and worked the road for you. It's a soft landing thing, to mix analogies. So the one thing that's interesting to me here is that, and something that I heard you, Chris, talk about in a different podcast, is that this secure by default is focusing heavily on the spinning up of resources and cloud infrastructure, and nothing is being said of the application itself. And so just to call out here, for example, they use the S3 buckets as the perennial example of resources in the cloud, right? I use that all the time myself. So when they are created, they are only accessible within their network by default. But why not take the step towards application and say, we're going to give you libraries that doesn't matter which language you're working on. Whenever you need crypto, you just put the thing that you want to encrypt, and it's going to take care of all the good stuff in the back with the keys and the correct algorithm, the cipher, the size. Why is it that the secure by default goes to infrastructure and stops there?
Well, so we probably should keep in mind what Atlassian is using this infrastructure for, right? We're talking about a build pipeline to build software and to host services, right? Atlassian obviously has products that get sold, right? That get delivered to people and they deploy it, as well as a hosting environment, right? They host a a SaaS version of their many of their tools. So first off, just in terms of the paved part, I think it's paved because the powers that be within their organization have created this development environment, right? That's the paved part, right? It sounds like there's a sub-organization within Atlassian that has created an environment that can be used by their developers to create the software, to create the hosted components, and those things are managed for them as part of their platform as a service, right? So they have a team that's building a platform as a service that then is provided to developers who then utilize that to then host software as a service offerings or build product. So I think in that regard is why stop at infrastructure? Well, that's what this team is building is our infrastructure components that are used by developers to build software components.
Let's think bigger, though, right? Let's think. We don't have to stay within the constraints of what this paper was just a jumping off point for.
But wait, Chris, just before we go there, Matt, I just ran a very quick search here on the CVE details. 404 CVEs by Atlassian.
Okay. And that's important in this conversation for what reason?
Because we are talking about their cloud environment and how protected it is and secure by default and all that. And meanwhile, there's been a number of recent failures in the application that they host, that they create, that they deploy, that they everything. And Gunnar completely agrees with me, as you can hear.
That was Skier, actually, but that's okay.
So I lost the accent. So
Shepherd versus Shepherd mix. Come on.
Yeah. So it's great. It's great that the environment gets secure and that forward development is secure by default, but it's missing. It's missing the rest. The data is still being touched by people who shouldn't be touching it. So
So I guess without knowing those details of the CVEs about when they came out versus when this infrastructure was put in place, True. Right? This is a recent report, so it could have just been deployed, True. Maybe to address those vulnerabilities that were identified. But also those vulnerabilities presumably were in the software packages or in the cloud services, the SaaS components that were delivered Whereas I'm reading, as we read this paper, it seems like it's about the platform that's provided to the developers is secure, not necessarily making the thing that gets delivered on top of it automatically secure.
So there's more to the story, right, than what this paper is exposing.
Right.
But I want to come back around because I want to get your take and Matt's as well on if we take this paved path analogy further beyond just secure infrastructure. You mentioned libraries. Like, should a set of libraries be on our paved path for developers that say, hey, if you're going to use crypto and we're using Node, here's the specific library that we're vetting and we are approving for use. What other pieces would exist in the paved path as well outside of just software libraries?
Look, if I could dream, I wouldn't even say here's the library that we as security have vetted and how we want you to use it. I think that in my perfect scenario, security would have the resources to step forward and say, here's a layer that we are putting between you and any library that we want you to have access to, where you get the security services. And we control the security services. We know what happens behind them, so that we'll never get into a point where, hey, there's a vulnerability, you have to update this library. Yes, I know we vetted it, but hey, there's a problem. So now go and update, and they'll say, oh, we can't update because backwards compatibility or anything else. So in my rosy view of the paved road, rather than giving a how-to, security would be able to give a function call and say, this is how we use crypto here in our place.
No. Now, are they doing that? I mean, again, this is where I think the timing question comes in of when this was introduced. If their security team is providing a platform as a service, presumably that platform is providing a set of services which could include a secure value store, right? As opposed to having to write or implement a secure value store on top of the platform, right? True. So that's where what you're trying to focus on.
I mean, that gets you secret protection. That doesn't get crypto. You, if you're doing something from a crypto perspective outside of TLS from browser to application, then there could be value in having this kind of standardized approach to crypto that's enforced at the platform level. Because, I think with secrets management, like that's a problem that's solved if you just tap into what the cloud provider does. I'm thinking of Amazon KMS, for example. Like, secrets management used to be the thing where we said, oh, that's a super hard problem. I don't feel like I need to answer that anymore. Like, secrets management is not a hard problem. It may be an arduous, time-consuming problem to implement and go through and clean up all your secrets that exist in your application, but the services are there in every cloud provider to do key management for me. So I think that's a paved road as well, key management.
Well, and actually, I think you've touched upon something else. Just as I reread that section, the very first statement that Bala, the very first comment that or quote that they have from Bala in this section is, we have a very clear set pattern on the type of hosted images that are allowed, and their default configurations are secure. So first off, they've chosen this platform as a service based on AWS. So already developers are in that mindset. When you're deploying services, you're on AWS. Mm-hmm. We're providing that middle tier, that platform as a service layer, define interfaces, whatever the case may be. Maybe there's this crypto services and secret stores and all this other stuff supplied by the platform, but it's on AWS. And so they've already made a technology decision and set the boundaries. We'll get into boundaries, I guess, in a little bit. And providing certain resources and knowledge of default, secure by default. And so that's actually really important, I think, because developers don't have to make the choice. Or rather, developers are restricted from making the choice, right? They're not being asked, okay, how do you want to deploy this? Oh, we're going to choose GCP, or we're going to use Azure, or whatever. Well, you're going to use this platform. This platform is built on AWS. And now you have, I don't want to say it, but we'll get there. Guardrails. You'll have guardrails on what you do. And we can, as a security team, we can know that what you're doing is secure.
So
Yeah, go ahead.
we've mentioned guardrails enough.
Wait,
We just have
no,
to
before
go there.
before we go there, Matt, just to take a lift on what you just said. This whole thing of secure by default and secure by design, actually just a secure by default, it makes our lives as threat modelers much easier. Because now we are telling people, hey, this is how we deploy things in here. This is how we build things in here. And rather than threat modeling everything all the time, I just want you to tell me where you are trying to go out of what we're putting down here. And then let's focus on that and threat model that. And then I'm going to tell you.
I'm going to disagree with you. I'm going to disagree with you just a little bit.
Oh, but
I think you're almost there. If you simply look at where you go outside of those boundaries, then you have the potential of missing. I think you have a potential of missing where gaps can occur, even without intent. Right. So we're making an assumption that the platform is secure. Right. Somebody must have threat modeled it.
mm-hmm. Yep.
Right. So to say that we can avoid that, we can avoid that as developers, but not necessarily as the organization. So maybe that's what I want to just highlight is I don't think we can completely ignore it if we're looking at it at the organizational level, but at a development level, we may be able to shortcut that effort.
If, again, in a perfect world, the organization decided these are the configurations that we consider secure. How did they get to that? Hopefully by building a threat model that cover all those configurations and saying, hey, we mitigated everything that we needed to mitigate, right? So they created this thing and called, if you do this, you are secure by default because you are falling inside our threat model. Now comes team ABC and says, hey guys, listen, we can't have what was the example they used? We can't have the S3 bucket that we are creating only accessible within Atlassian. We have to cooperate with somebody. So now you have that delta, that specific delta, that story to go and look at. So you are reducing the scope of the new threat model by orders of magnitude. Right. And now we go back to what you said, which is, I agree completely, you caught that. But what I say is, by reducing that scope, the amount of second and third order implications that change could have in the overall already threat modeled figure is much smaller, right? So yes, we go back to the big threat model in the sky, but the changes that could happen are different.
Absolutely, and I think that's really the key part there also is the delta.
Yes.
Whoever does that analysis originally needs to share that.
Yes.
Because that's where you start from.
Yes.
Right. And you can look for new openings. You can look for gaps. You can look for attempts to modify the known configuration or the understood configuration.
It's the butterfly effect of threat modeling, right? You could make a very small change in here, and that's going to reverberate across the structure, and it's going to cause a much bigger gap somewhere else.
Well, and we see it we see that all the time, right? Code changes, right? You're looking at source code and you're doing code review and you go, oh, yeah, we assume that it works. Oh, yeah, document that assumption because guess what? A year from now, somebody's going to make a modification that's going to completely violate that assumption. Now you're all hosed, right?
Butterflies everywhere.
The butterfly effect. The butterfly effect of threat modeling. Like that's trademark, patent pending. Izar It's a good way to think about drift in a technology product, and it's the reason we want to revisit threat models at some increment of time because drift does occur. Butterfly wings flap off to the side, and all of a sudden, somebody's using a bad library or
it's chaos engineering at a design level.
Yeah, that's another trademark patent pending. All right, so let's talk about guardrails.
All right, we'll skip the second one. The third part.
We'll come back if we have time because I think guardrails go along with the paved path, like the secure by default approach, and the guardrails are two things that are supporting constructs here. And so I've heard security guardrails thrown around as a term for the last number of years, but let's stop and think about like. What is a security guardrail? And I feel like Matt needs a moment to draw a picture. So Izar, what's a security guardrail?
A guardrail, the analogy when it comes up to me, the feeling is that where do you put guardrails? You put guardrails in places in the road where if you go beyond the thing, terrible things happen, right? So you put it in like steep curves and things like that. So it's not like you're putting it everywhere. You're not closing people on that road and saying you cannot get out of the road. You are saying we have identified places in this road where horrible things could happen if you drive out of it. So we're going to put this piece of metal in here to A, show you that you shouldn't go past it, and B, if you happen to really, really go fast and go against it, it's going to sort of try and stop you. Now, the analogy is imperfect because we know that guardrails don't really stop horrible accidents from happening. Or perhaps the analogy is perfect because guardrails don't stop horrible accidents from happening. But the fact that you have that one more bump in the road between driving and disaster, I think it's worthy enough to justify the efforts.
Yeah.
It's a stop from chaos. It's a step away from chaos. Chaos being the developer can do whatever they want with anything that they want. The guardrails hold them into the road, but don't force them to stay in one particular lane and have a kind of fixed way. Like, oh, you have to do it that way. It gives them some flexibility.
I'm going to take a bit of the responsibility off the developer here. It's not that it's stopping them from doing what they want. It's also stopping them from unintended consequences to things that they didn't know might happen. And it goes back to do developers have to know everything about security? No, they need to know not to break the guardrails.
So interesting. That's an interesting way of describing it. It comes down to I think that it's an interesting thing concept to think about here about how much should developers be aware of the change of the things that they're making, what they do, like how much conscious thought should they have, or how much liability should they? And I want to use liability in not the legal ways, not the legal terms side of things, but should they ever, if they can do whatever they want within that paved road and they hit the guardrails, as long as they don't break the guardrails, it protects them from danger, protects them from themselves to some extent. Is that okay? That developers are free to operate in that environment? Maybe another analogy here might be: have you ever gone bowling and you got gutters, right? And you have those bumpers that can come out, they can put up. It prevents people from going in the gutter until they learn how to shoot down the lane, but then you take it away, and now you have the gutters as your protection, right, from jumping lanes and everything. I guess how much should developers be oblivious to what's going on versus being prevented?
So I think that before people started talking about guardrails, we were talking a lot about hand-holding, right? And hand-holding always brings the idea of the parental guidance. Hey, I know better than you. Here's my advice. Here's what you should do. That one I think is offensive to developers, very smart people who can most of the time learn better than us and can teach us. And B, it's extremely limiting because it says there is this one way of doing things and this is how I want you to do from now on, right? Or at least until you are experienced enough to figure out by yourself what's the other right ways of doing it. Guardrails, on the other hand, they try to limit the scope of where they might even go from the beginning. So you're not saying there's only one way of doing the right thing. You're saying there's a limited amount of things that you can do before you hit the boundary of the right thing. Mm-hmm. So I feel that Guardrail is a bit more trusting of the developer. And it's not trying to tell them you can't do what you want to do, but it's saying there is a limit to the latitude that you have to do the things that you want to do.
Yeah. Can I actually, I want to, I'm having a hard time with this, and maybe you guys can correct me here. If somebody builds a platform as a service and provides a bunch of services and then automates and puts up guardrails. Ignore for the moment the automation part. The automation part, I think, is actually really important. We should touch upon that. But the putting guardrails in the first place, aren't you limiting choice in doing so? Somebody outside the development organization has decided on AWS and all the services. Somebody outside the development organization has said, these are the interfaces you should be using. Somebody outside the development organization said, this is how you're going to do privileged access. How much is actually under the control of developers?
Well, they still get to build the feature, right? Like you're still like, we're not talking about the thing that we're delivering to the customer by way of the feature. Mm-hmm. The guardrails are the things that are helping us to keep that feature so that it's as secure as we possibly can get it when it does roll into production. Because when I think about other guardrails, I mean, I would say that security tools in the pipeline, those are guardrails as well. They are helping us to ensure we're not drifting too far away, or we're not having, software composition analysis is helping us to not have super old dependencies that are riddled with vulnerabilities. If we configure it properly, that is a guardrail. It's kind of I don't have a way to get around it. Like that's an example of one where there's only really one way to, like, I don't have a lot of creativity in fixing a dependency vulnerability. I guess I do. I guess I could go get the library. I could customize my own fix for it, or I could upload or upgrade my my library. Now I'm going to take whatever the quickest way is. I'm not going to go fix it myself. But like, I think about the developers still have the creativity, the flexibility, the ingenuity to build the feature that ultimately goes to the customer. And what we're doing with guardrails and paved roads is we're giving them a platform to build on top of, where they don't have to worry about identity and access management. Like there's a series of services that are available. They don't have to worry about secrets management. They just have to follow the rules that have been established.
But you know what? Now what both of you just said got me thinking in a different way. It's not really that it's new, guardrails or hand holding. We're talking about the funnel here. Okay, think about this. You're developing close to the iron now. You're working on the processor. You have ring 0, you have ring 6, you have all that good stuff. Then you put an operating system on top of that, and you just funneled a bit. All of a sudden, you don't have ring 0 all the time. And then on top of that, you put another layer that now describes the authorization that you need for APIs and stuff like that. So you just go funneling up until you get to this top layer where you say, okay, developer, now you can go and do whatever you want in double quotes. And now we are just funneling a bit more by saying, you can do whatever you want inside this mass limit that we just gave you. And it could be that with security by default, security by design, and the guardrails, we are finally reaching a point where we have funneled as much as we could without breaking the freedom of the developer to actually do what they need to do as opposed to what they want to do.
Yeah.
Does that make sense out of my head?
It does, actually. It does. It wasn't where I was going. I did actually have an ulterior motive in the questioning here. But I'm going to just say it. What goes around comes around. Sorry, that's the wrong phrase. Sorry. What's old is new again.
Yes.
Right.
All that has happened will happen again. Yeah.
Yeah. So, right. So remember when we used to have tool development teams and configuration management teams that were responsible for setting up environments and creating APIs and creating SDKs and creating those funnels and setting those guardrails, right? So you had a tools team that managed your ClearCase or whatever and your config specs.
ClearCase.
So right. I'm going to go back. Like, I'm old too, right? So
sorry.
So so you're going to have somebody managing your source control and somebody managing your development environment and your production, non-production environments, and those funnels that Izar was just talking about, right? All of that is starting to come back now. in this way, in a new environment, right? So that was physical hosts being managed and physical assets being managed, and developers had network access and root access, ring zero access to some extent. And now we're in the cloud. And so now it's different. But we're putting those same processes back in place so that developers no longer, this is, I guess, the whole concept of DevOps, right? DevOps was developers had to take care of all of that themselves now. And that means that we're doing a lot of extra work. Oh, what tools do I have to deploy to make static code analysis or software composition analysis work? And I have to manage all of that in addition to doing the creative stuff. So now we can create these filters. A team, a tools team, whatever, can create these funnels and create these guardrails and create these services that developers then can do creative stuff on top of. That's what it sounds like this is leading to and or implementing. Maybe it's not intentionally that way, but that's what it sounds like.
No, and I love the fact that, like, I hadn't thought of this. Like, you're really stretching my mind here because DevOps was almost an opposite reaction to having tools teams and having people that ran stuff in production. But now it's almost like, I think we got to break DevOps into different. I think DevOps is much more than developers making things. Developers just basically building on top of a framework that represents production, so there is no longer a disconnect. I feel like DevOps has gone so much further than that. When you think about CI/CD, and when I think DevOps, I think speed. I think being able to push 50 or 5,000 times a day. That's the benefit. It's pipelines. It's automation. It's so much more than what the original reason DevOps was created. But to your point, Matt, like, we're almost coming back. We're going back around the circle again to say, well, guardrails are going to constrain what people can do, just like tools teams used to provide the environments that then now I would argue in those earlier days, the tools teams, a lot of us didn't follow what the tools team said we were supposed to do.
Yeah.
And so, a lot of other people didn't follow what the tools teams, I didn't mean us. What the tools team said we had to do.
The guardrails were sort of like suggestions, not really.
They were made of cheese, Swiss cheese or whatever. Right. Like, you could easily bump up and just go past.
No, but that's actually the interesting, right? So CI/CD is a good example, right? The tools team used to manage the CI/CD pipeline, let the developers do their creative work. Then DevOps happened, and the developers took over responsibility, and we're doing the creative work. And now we're coming back to a tools team is deploying CI/CD, and developers can do creative work.
But it's a strange thing, Chris. When we talk CI/CDs, you go back to the speed, and I don't know you guys, but recently I have had the experience of trying to write something, and I have the very clear idea of what I want to write, and I sit down to write. And then it begins. Okay, I need this library, but that library needs that version of the interpreter. Okay, so I need a virtual environment. Okay, so I need to download something that creates the virtual environment, but then I have to write a text file that describes the environment, and then I have to post this somewhere, and it's basically 6 hours of work before I can write one line of the thing that I actually sat down to write. So, yeah, CI/CD doesn't really bring me speed to mind.
It doesn't bring you as an individual if you're doing all the work. But imagine if there's somebody already providing that service to you that you can then sit down and start coding it.
Right. So that was my next step, which is where when I hear CI/CD, the big advantage that jumps to my mind, and as a security professional, I think, is the repeatability. The trust that I have that the processes are going to happen the same way in the same order every single time that I fire that thing. Right?
I mean, it's small batch size too, right? That was the whole beauty of CI/CD is we can make a batch size of a couple of lines of code changed, and we get a lot better fidelity as to who broke the build and who screwed up versus the waterfall method where we would wait till the end and we deal with this hell on earth called integration.
Right.
Where we try to make all of our code work together, and it would take an additional, as much time as it took us separately to build it, it would take at least twice as much time to get it all to work together. And by the time we released it, nobody even cared.
Right. So the guardrails to me go much more towards maintaining that trust on the reliability of the CI/CD than going for the speed. Because even places that, deploy 500 times a day, it's not like you have the same developer 20 times during a day, adding new libraries and adding new packages and adding whatnot. It takes longer to add a package to something that's running than in between PRs, right? So I think that the guardrails, again, they come both as a mechanism to reduce the cognitive workload on the developer, the things that they have to learn to keep inside those boundaries. And the other side of the guardrail, looking from the outside in, they are not going to do anything that's going to break the repeatability and the trust that I have on the other processes that I have around the thing that's being produced. So the guardrails, the guardrails keep people from going out of the paved road, but they keep the paved road from collapsing on them.
And with the automation part, so the other aspect here is the automation. If there is a break in the pavement, right? So if it's a heavily traveled road and you got a monster truck driving over it and it breaks the pavement, you can repave it or patch it, without having to send a whole work crew. Or the guardrail, somebody bumps against the guardrail and bends it, you have automation in place. Or when you're building new road, paving new territory, or putting up new guardrails, it's automated. I mean, this is a wonderful thing, right? The ability to not only create new structure, but also look at what you did put in place and make sure it's still functioning the way you expect it to, right?
Yeah.
And that's the very last line in that section, right? The automation can enable auditing, which allows you to meet compliance. Well, yes, that's true. Yes, you can do that. You can audit for compliance purposes, but you can also audit for extending that trust to your developers. The system is working the way you expect it to. You can rely on it.
Yeah, and look at the example that Bala put in here in that first paragraph. I think it's just good to revisit that in regards of the security guardrails. So, Bala often hears from engineers that they need admin rights. I mean, who doesn't? We all need admin rights for their day-to-day, such as provisioning certain services in AWS. For those in similar situations, he advises teams ask themselves, is there a way for me to do this with code, push it, have it run on its own? So he's defining a service that will provide the service provisioning so that I don't have to go into IAM and AWS and say, everyone's admin, everyone has full privileges to everything. So, which is a great security principle that none of us are going to argue that you should give people admin rights. Everybody should have admin rights in a cloud deployment. And so this is a case where a security guardrail insulates the entire infrastructure, the entire cloud world for this particular company from having too many people with admin rights.
So one thing that I hear a lot from developers about the principle of least privilege is, why should I constrain myself? I don't know if tomorrow I'm going to need something that needs more than the rights that I'm giving it right now, right? So they're forward looking. I may not need it now, but I may need tomorrow. Why should I remember that I have this mechanism thing in place? Let me just be admin and do whatever I want. But I think that when you put that together with Bala calls out defined infrastructure as code, we know that code is something that today we know how to automatically interpret and check and link and figure out things. Like, we have the tools. They may be, that's a whole completely different discussion, but we have the tools.
Mm-hmm.
So
we have some tools. We have the power.
We have the power. We have the technology. So by forcing developers to explicitly declare themselves what level, to go back to the example here, what level of rights they need, we as security people get the enforcement of least privilege. They get to ignore it because we are telling them these are the Lego pieces that you have to build. And then what gets solved is one of the bigger problems, I think, of least privilege that always haunted us security professionals, which is, okay, we went into the threat model, we defined that these would be the least privileges. But now how do we check that this actually got done? So by being in the boundaries of infrastructure as code, as part of the guardrails, we as professionals have the assurance that we have a place to go and look and automatically parse and check that these are indeed the rights that are there. And then we have the whole mechanism at the end of the pipeline when the thing's already deployed to go and query the structures of the cloud system. Are these actually the rights that are in place? So now we have multiple checkpoints to figure out the same powerful thing that before we didn't have as much visibility on top of. And we can go and say, I will do these things because, wait for it, they are reasonable. It's reasonable to ask developers, hey, define your infrastructure as code and take least privilege into account. It's reasonable to ask DevOps people to say, use infrastructure as code, and it's reasonable to ask our security tools to check that code for what we are expecting to see.
Yeah.
It's interesting. In all of what you just described, you could take out the cloud aspect and that would still be true.
Exactly.
And that's really important, right? Cloud is not the drive, was maybe the driver for this, but cloud is not necessarily the sole beneficiary of this.
Yeah, this is it's been a good spirited debate as always. So we didn't really have time to talk about split cloud environments and have different levels of control. I think we're all likely going to be in agreement that that's a good practice. I don't think any of us are going to be like, well, I really think we should put everything in one VPC and just let everything talk to everything, give everyone admin rights. And Izar, let the record show, Izar just fixed all of his infrastructure as code and he deployed and he's good. Oh, we went green.
I wish I had more guardrails.
And more paved roads and guardrails and more illustrations for how we can call this. So, it's been a fun conversation here on the security table, and we will continue to drive down the paved roads and building more of the security guardrails. And I forgot the other illustration.
And making everything secure by default.
That's okay. Secure by default. There you go. So, once again, thanks for listening to this episode of the Security Table.